Hi, my name is Jacob, and I'm a consultant here at the Math Lab. In the previous video, I showed you a few ways of obtaining or creating STL files, and in this video, I'm going to show you how to use Cura to turn those files into G-code for the 3D printer. So first, I want to show you how to load files into Cura. Now, if there is an object that's already on the build plate when you open up Cura, what you have to do first is go to File, New Project. And what that's going to do is that's going to clear away any of the old settings and any of the old changes without changing the profile that you should be using. Once you've had done that, you can then go to File, Open Files, and find your STL file. You can also use the folder icon, the open file icon on the left side of the screen, and that will also allow for you to go searching for the file. Once the object has loaded into Cura, you can select it, and when you do, there will be a series of icons on the left-hand side below the open file icon that allow for you to do things such as move the object, scale it, rotate it, mirror it. There's some per model settings and support blockers, but we're not going to get into those last two. But first, before we get into any of those settings, to be able to maneuver around in Cura, there's a couple things you have to know. If you click and hold the scroll wheel, you'll be able to move the build plate without changing your point of view. If you hold the right click, you can then rotate your view any way you want. The left mouse button does not allow for you to move your view. It only allows for you to select the object. Now, if you need to adjust your view, there's also preset views at the top right of the viewing area. So there's an isometric, and then each of the sides, a top, another side, and the back. Generally, though, you want to use the isometric view. Now, if you've done that and it's zoomed out on you, you can use the scroll wheel to zoom in and out just by rolling the wheel as you would for scrolling up and down a page. After you have gotten into a view that you can see everything and you feel comfortable with, select your object, and then we can go to the move, and we can actually tell it in the X, Y, and Z which ways we want it to move. Now, for the object I've chosen, I don't want it to move. I want it to stay in the center of the build plate. However, I don't like the way that it is currently oriented. So I'm going to click on the rotate, and you'll notice that there are these circles that rotate in different ways. I'm going to want to choose the red circle, and I'm going to want to rotate it. And as you can see, there is a degree measurement. So in this case, I want to move it 90 degrees and rotate it so that way I have a flat face on the build plate. You also have lay flat and reset. Reset is just going to reset it back to the original orientation that it loaded the file in. And lay flat is where Cura is going to do its best to lay it down flat. However, it doesn't always work the best. So I just recommend that you just do it yourself, and you can manipulate your view and make sure that it's actually laying flat. Once you've gotten it to an orientation where it's either laying flat, it has good contact surface, and that's where you're going to have to work with a Math Lab consultant to make sure that you have that, or you have the best possible orientation. You can then move on to adjusting some of the settings in the print setup so that way you can slice the file. As I mentioned, though, I said you could scale the object in, so there's two ways you can do that. There's snap scaling and uniform scaling. Uniform scaling is where if you adjust one of the scales for either the X, Y, or Z axis, it applies that exact same change to the other ones. Now, that's typically what you're going to want to use because it keeps everything in proportion, just ends up making the part bigger or smaller depending on your preference. There's also a reset button, and snap scaling allows for you to just be able to grab onto any of the boxes on the axes and be able to move it. And if uniform scaling selected, it too will also scale everything uniformly. When you want to scale it in the X and Y but not affect the Z, that's when you would want to unclick the uniform scaling box so that way you can adjust those parameters independently and they won't affect the other ones. Now that I've shown you how to load the file and scale it and manipulate it to the way that you want it, we are going to move on to going through the settings so that way you can print the object. So starting at the very top, there's quality, shell, infill, material, speed, support, build plate adhesion, and then some other settings that I'm not going to get into today. Now, most of these settings you don't have to change, and I will point out the ones that you do change. But if you are curious as to what the settings do, you can simply hover on it and a box will show up to the left side on the viewing part of the program, and it will give a brief description of what that setting does. Like I said, most of these settings you don't have to change, but if you are curious, feel free to check those out on your own. As I said, most of these settings are not going to be changed. However, one setting that you can change is infill density. Infill density is just simply the percentage of airspace inside of the part that will be filled in with plastic. Some advantages to having more infill is that you typically will have a stronger part because there's more material holding the layers together, and you generally can get better print quality because there's more supporting material inside the print to help out with overhangs and other complex geometry. However, when you increase the infill density, you also increase the time needed to print it because the printer has to take more time to actually print that infill. Typically, you want to keep it around 20%, 25%. You can go lower, you can go higher. However, you really don't need a crazy amount of infill. If you really wanted to, you could set it to 100%, and that would be a solid plastic part. However, the print time on it would be so drastically long that it makes no sense to do so. Hence why I recommend staying at around 20% infill. Now for material, you'll see that there's the printing temperatures. If you're printing in PLA, then I highly recommend that the temperature be kept at 210 degrees Celsius for all of the print temperatures. Be that the default print temperature, the printing temperature, the initial layer for the printing temperature, initial printing temperature, and the final printing temperature. All of those I recommend keeping at 210. However, if you are printing with a material such as PETG, I recommend that you change the temperature for all those settings to 260 degrees Celsius. After ensuring that the temperatures are correct for the proper material, you don't have to change any other settings in the material section. Print speed settings don't have to be changed, but those are just the settings at which the printer will move or print the support or infill at. Support material is relatively subjective in that some objects need lots of support, some objects don't need any. It depends on the geometry and shape of the part. However, if you need support, make sure that the box for generate support has a check mark inside of it, and then also make sure you choose the appropriate support material. Touching build plate will just simply do from the build plate up to the part, whereas everywhere will do that, and then it will also put support material inside or off of parts depending on the shape of the object itself. As for the other settings, those do not need to be changed. And build plate adhesion. This serves two roles. The first being that it primes the nozzle, and the second being is that it helps make sure that the object itself stays where you want it to print. Because what you don't want to happen is that the part or object starts moving while it's printing, because then you're no longer going to get the object that you want. You're going to get some horrible monster of a part. With that being said, you have really 4 different options in terms of build plate adhesion. There's skirt, brim, raft, and none. Skirt and brim are very similar, except that skirt will be a ring around the outside of the part away from it, so it's not touching, whereas a brim will be touching the part as it's printing. What's going to happen is it will print the brim first. That'll be a more direct outline, and then it will then start printing the part off of the brim, but it will still have some of the first layer still touching the build plate itself. Now a raft is different in that it actually will be a couple layers of material that is not part of the part or object. It is just there to absorb any imperfections in the build plate. Those imperfections don't make it into the final object. It will have to be removed just like a brim would in order to have the actual object itself. Once you have all your settings to be what you want them to be, you can then click prepare, at which point it will then slice the object before allowing you to save it to where you want to find it later. Make sure that when you are saving the file that it is labeled as a gcode with the .gcode extension after the file name. Otherwise, it will not save as gcode and you will not be able to upload it into Athena. Once you have saved the file to where you want it to go, you do not need to exit out of Cura. You can just simply minimize it. That is all for this video. In the next video, I will show you how to upload the gcode file into Athena so that way you can actually print the object.